For an example of a fractal, let's start with an equilateral triangle. Then, let's draw another equilateral triangle in the middle of each side. Then, let's repeat this step on all 12 sides of our shape. This shape is called a Koch snowflake, and it has a special property. No matter where I look or how much I zoom in, I will see the same pattern over and over. Neighboring patterns like this, that on any scale or any level of zoom look roughly the same, are called fractals. We can actually draw a Koch snowflake by repeatedly graphing a mathematical equation. Each time we add a triangle, one side of the Koch snowflake will turn into 4. After the first repetition, we will get 3 times 4 to the first, or 12 sides. After the second repetition, we will get 3 times 4 to the second, or 48 sides. So, after the repetition number of n, we will have 3 times 4 to the n sides. If we do this an infinite number of times, we will get infinity many sides. The history of fractals dates back to 1975, when fractals were discovered by Mandelbrot. Well, maybe not discovered, but finally put into words. He explained them as being geometric shapes that, when divided into parts, each part would be a smaller replica of the whole shape. He came up with the term fractal as a new scientific term for this mathematical expression. The word is actually an adaptation from the Latin word fractus. The Latin word fractus means broken or fractured. The concepts behind fractals had been around for centuries, but it was not until Mandelbrot had his realization that fractals were discovered. In addition, fractals are a very important part in biological studies. For example, a lot of objects in nature are composed of complex figures that are otherwise not possible to be defined. Most natural objects such as clouds and organic structures resemble fractals. As such, fractals can be used to capture images of these complex structures. Fractals are considered to be important because they define images that are otherwise cannot be defined by Euclidean geometry. Fractals are described using algorithms that deal with objects that don't have integer dimensions. Some of these more prominent examples of fractals are the Cantor set, the Koch curve, the Skiprowski triangle, the Mandelbrot set, and the Lorenz model. Fractals help us study and understand important scientific concepts, such as the way bacteria grows, pattern in freezing water, and brainwaves. Their formulas have made many scientific breakthroughs possible. While cell phones antennas use a fractal pattern to pick up the signal better and pick up a wider range of signals rather than a single antenna. Anything with a rhythm or pattern has a chance of being very fractal-like.